Okay, I have started recording, so I think everything is okay. Stochastic calculus. Now I think everything is fine. Class 1A. Okay, if you have any questions, just be brave and ask them. I'd like to foster questions because I think you have some fear, unreasonable fear to ask questions, but I'd like to encourage you. So if you have any questions, just be brave and ask them. Okay, so no questions. Let's solve some problems. First, let's consider a stochastic process with a corresponding problem one. Problem one. Let's consider the sequence of random variables x1, x2, x3, and so on. Xi are independent, and I know their distribution. So they have the following distribution. There are only two values possible, -1 and 1, and probability that xi is equal to value to a particular value is either 0.4 or 0.6. So are independent and identically distributed. And let's create also Sn. That is x1 plus x2 plus xn with initial condition as 0 equal to 0. So I have created two random processes, the random process x1, x2, x3, and the random process s1, s2, s3. I will also create a filtration. So my filtration will be given by, I just observe the value of x. So at time n, I have observed x1, x2, x3, and so on. So well, it's the setup. And now the questions. First question, let's speak a little bit about Sigma algebras. How many events are there in F1, F2? So just to understand better the Sigma algebras. Now B is the process Xn adapted to filtration Fn. Is the process Fn adapted to filtration Fn. C, we will check whether Xn is a martingale or not. The same question for the random process Fn. And finally, yeah, let's start, because when I write a lot of questions, then you do not think, you just copy them. So let's start to think, to better understand what's going on. So is the setup of the problem, is it clear? So first question, everything is fine. So I don't yet ask about the solution, but is everything clear in the setup of the problem?
Excuse me, Boris, could you please briefly remind us what is filtration?
Filtration is a growing sequence of Sigma algebras. So filtration is a sequence of Sigma algebras. Sequence sequence of sigma algebras that is growing. You know more and more, because sigma algebras, they unique, probably not unique, but the main reason of sigma algebras is to convey information. So you know more and more, and so basically that is.
So in other words, filtration is, yes, about the information that it grows from time to time, and from time to time we'll know more and more and more and more.
Yeah.
Observing the past events.
Sorry?
Observing past, what happened in the past, right?
Yes.
Okay, thank you.
And the formal definition is just growing sequence of sigma algebras, nothing more. Okay, so you are a little bit shy to answer. Just be brave and answer. Yes, it's clear. The setup of the problem is clear. Just write plus in the chat, but be active, because otherwise it's a stupid class. Because it's very difficult to me to do something online without your reaction. So I have asked, is the setup clear? I understand that it's very difficult to answer yes or no, because you need to answer, but just write plus, minus. Is the setup of the problem clear? Question.
Yes, it's clear. It's clear.
Yeah, thank you. Okay, let's go on, but be active, because otherwise it's like a lecture. You can look in the Zastavniak book. There are a lot of books. You can look Baldi. So my only difference is that I can react to your comments, to your questions. That's a unique use of classes. So if there are no questions, just look in the book. What is the advantage? Why you are here? So be brave. It's not so hard. Okay, but it's strange to me. Don't miss your opportunity to ask question, to answer. Okay, let's move on. Let's just first question. Now, the setup of the problem is clear. Okay, what is F1? Just let's calculate it. What is F1? What do we know at the moment 1? At the moment 1, F1 is sigma of x1. So I know the value of x1. So some events I can, there are some events that I'm sure about whether they have happened or not. Let me provide you some examples. So I will provide some events, and you will answer whether I'm sure about the occurrence of these events or not. So let's create some events like x1 is 1, first event. X1 is greater than x2. X1 squared is 1. X2 is 5. What else? X1 times X2 is 1. And now let's consider the first moment of time. So we have F1, that is my knowledge. So it's the list of events about which I'm sure whether they have happened or not. So let's check whether my information contained in F1, whether this list F1 contains these events. Let me name them A, B, C, D, E. Is event A in F1?
Yes.
Yes.
Yes. Okay, is event B in F1?
No.
Why?
Because we haven't observed x2 yet.
This is x2, but that's okay. Okay, yeah, I agree that is not in F1. C, is it in F1 or not?
Yes.
Yes.
Yes. D, is it in F1 or not?
No.
Yes, because x2 cannot be 5. So I'm pretty sure, even I'm sure this will never happen. According to the rules of the game, x is either 1 or -1. So
yeah, exactly.
this is just a little bit masked empty set. But in my setup, this is just an empty set, but in disguise. Yeah, and the empty set, I'm pretty sure this will never happen. And even in the first moment of time, I'm sure this has not happened. Okay. So here the answer is yes. And here x1 times x2 is 1. Is it in Sigma Algebra? F1?
No.
No. Okay. Then yes, you are right. Basically, with just a small trick. Yeah. But yeah, so if I consider an event like f, like sine of x2 squared plus cosine of x2 squared is equal to 1. From the first point of view, you see x2 is there, but I'm sure that this event will happen. Yeah, x2 is in the text of the event, but this will happen for sure. Yeah, this is just omega in disguise, because for every possible number, the sum of sine squared and cosine squared is 1. So it's just an event which will always happen. So it is in F1. So just don't be tricked by appearance. Yeah, x2 should be in. So it should play some. It should be essential. Yeah, it's not just masked omega or empty set in disguise. Okay, so we know that there is at least 1, 2, 3, at least 3 events are there. And how many events there are in F1?
Boris Borisovich, excuse me, can I ask a question about x2? So we say that B is not happening because x2 is not observed.
No, I don't. So I don't say that B will not happen. I just say my. What do I say? I am not sure. I say that B is not part of my knowledge at moment 1. I don't know whether it will happen or not. It may happen.
Okay, I understand.
We can calculate probability, but I'm not interested in probability now.
So in F, we are completely sure, and that's why it doesn't matter it's x1 or x2, right?
Yeah. Yeah.
Thanks.
Yeah. So what is a Sigma algebra? It's a list of events, and for each event in the list, you are sure whether you have enough information to say whether the event has happened or not happened. Okay, so I have at moment time 1, I have enough information to say whether x1 is 1. So A is in the list F1. At moment time 1, I have enough information to say whether x2 is 5. I will say, no, x2 is not equal to 5, even if the time t is 1. My information is sufficient to check whether the event D has happened or not. So I'm not just looking at the number, oh, x2, I don't know yet x2, but maybe something is obvious. So for example, something like, if I would change like h, like x2 plus 1 is greater than x1 or equal to, this event is also in F1, because I'm pretty sure that this will happen. No, plus, no, plus 2, plus 2, and it will happen for sure. Yeah. Okay.
Can I please ask a question too?
Yes. It's my only advantage. So be brave and ask questions.
So for in B case, for instance, we already know what is x1, and but if we know that x1 is 1, then it works. We can be pretty much sure as well. But if it's like negative 1,
we have described it when we have described Sigma algebra. We need for sure in any case. So if you're right that if x1 is 1, yes, we know. But if x1 is minus 1, we don't know. And in the description of Sigma algebra, we have stated that for any state of the nature, we should know. and you say, there is one state of the nature when we know. Yes, there is, but not always. So we include in Sigma algebra only events about the occurrence of which we are sure in any case. Okay?
Yeah.
The formal mathematical definition is just you take, so what is the formal mathematical definition? So you just take X, all events that can be formulated in terms of X. Sorry, it's not 0. -1, 1, and you combine them, and basically you obtain 4 events. So F1 just contains 4 events. X1 is -1, X1 is 1, empty set, and omega. Okay?
Yeah, clear.
Yeah. Let's go on. Who can say about F2? How many events are there? Oh, I will give you 3 or 4 minutes to think how many events are there.
Maybe just the same set, like x2 minus 1, x2 1, empty set, and omega. No?
No, because F2, according to our definition,
Yes.
contains it's not just I have you say about the case when Fn is just sigma of xn.
Yeah, got it.
I do not forget past values. So in your imaginary case, when I forget past values, yes, you are right. But in my case, I do not forget past information. So that's why it's filtration. In your case, it would not be a filtration.
Maybe it can be 1, 1, -1, -1, 1, -1, and etc. No?
Yeah, and how many events? Yeah, basically, in general, you are right. So you should first start with the primitive events. Yeah, there are some primitive events like x1 equal to -1, x2 equal to -1. You are sure about, you have enough information. In any case, you can say whether this event has happened or not. Yes, there is -1, 1. 1, -1. Yes, there are 4, let's say, primitive events. Yes, but you can also combine them. Yeah.
Yeah.
And how many events in total? Because you have something like x1 is greater or equal than x2. Yeah, it's a combination of primitive events. You have this one is here, that one is here, and that one is here. So you can combine to make complex events in terms of x1 and x2. And so how many events in total? Ten. A little bit more. So basically, you have 4 primitive events, and you can combine them. For example, you can take the first, like in my case, I have not combined the second one, but I have combined the 3 remaining events in my complex event. So I can also combine 2 events, like if I combine, for example, these 2 events in one, I will get an event x2 is equal to 1. And I have 4 primitive events, and for each primitive event, I can just write like plus or minus. Yeah, that means I take these events in the combination, or I do not take these events in a combination. So Now we have a correct answer in chat because we have 2 to the power 4 combinations, because you can either take or do not include each primitive event in the combination. And basically you have 4 primitive events, each can be included or not included. So you have 2 to the power 4 possibilities, and it's 16 events in this Sigma algebra. Yeah, it's 16 events. For example, if you do not take first primitive event, second primitive event, and so on, you will obtain the corresponding empty set. If you take all the events in the combination, you will obtain omega. If you take, I don't know, the first one, the second one, you will obtain x1 is -1, and so on. Okay, so F2 Sigma algebra, it contains 16 events. So my main point that we just understand better what a Sigma algebra is just a big list of events. And honestly speaking, they are so big, 16 events, to list them completely, it's a long way to do. So basically, we will just use the notation like F2 is generated by all information that comes from observing x1 and x2. Yeah. So yeah.
Our primitive events are x1, x2, and their combinations, or like these 4 at the top.
X1 is not an event at all.
Mm-hmm.
X1 is a random variable. Yeah, X1 is a random variable. What I call primitive events. Primitive events. It's x1 is -1, x2 is -1. They are listed, the first 4 events, I call them primitive events because they cannot be separated into smaller sub-events. You cannot say that, so let it be A. Yeah, let it be A, B. You cannot separate A into 2 sub-events, A1 and A2. You cannot, you have no information to separate sub-cases. Yeah. You have no.
And the event, like as you wrote, x2 is equal to 1, and that's it, like in green. Is it event as well, or just?
Yeah, it's event, but not primitive. Yeah, it's a combination. You have 4 primitive events, A, B, C, and D, and every other event can be written as a union of some primitive events. This green x2 is equal to 1 can be written as a union of B and D. Yeah.
Yeah. Got it. Thanks.
This is B union D. This is A union C union D. Okay, so I have 16 events about which I'm sure whether they have happened or not happened. This is my information. This is my knowledge described by 16 events. And among these 16 events, there are 4 primitive events that cannot be broken further into pieces. And every other event is a combination union of some, maybe all, maybe none, maybe 2, maybe 3 primitive events. Okay, so a small resume. We have just found some Sigma algebras. We see that Sigma algebras are very complex objects. So you may try to check how many events there are in F3, how many events in F3, then much, much more. How many events in F3? It's a big Sigma algebras, even F3. And you may also ask how many events there are in F100. It's a good question. Okay, let's move on. Point B, is xn, is it adapted to fn? So do we have enough information in fn to calculate the value of xn?
But that's what actually the equation means, right? When it say xn is adapted to fn,
Yeah.
this means that fn contains enough information to calculate xn.
Yeah.
Okay.
Yeah, the answer is yes, by construction. Yes, because it's easy. Fn contains enough information to calculate x1, x2, x3, xn. So by construction, fn is information we need to know. So what does it mean formally? So it's the smallest Sigma algebra, smallest Sigma algebra containing all events like x1 is less than a, x2 is less than a, x3 is less than a, xn is less than a, for all real a. So we have enough information to calculate the value of xn in fn. And if you observe that Sn is just the sum of them, yeah. And basically, if you know x1, x2, x3, and so on, then basically you have enough information to calculate Sn, yeah. So Sn is adapted to Fn, because in Fn you have enough information to calculate every value of x1, x2, xn. But if you can calculate every value of x1, x2, xn, then you know the sum. Evgeny asked in the chat whether the number of events is 2 to the power 8 in F3. In F3, I think yes, you have 8 primitive events and 2 to the power to the number. Yeah, you're right. Yeah, 2 to the power 8. Okay, now let's check whether they are martingales. See, is xn, is it is a martingale with respect to filtration fn?
Excuse me, and before it was that Sn is adapted to fn, right?
Yeah, all sequences are adapted. So we have in fn contains enough information to calculate xn and sn. So what does it mean adapted? For every n, we have enough information to calculate xn and sn. Okay, is it a martingale? So what we need to check? We need to check that first, we have already checked that xn is adapted to fn, and but we have already checked in the previous. And the one property of martingale that we need to check is that the best prediction of future value of, I don't know, xt given fs should be xs for s less than t. So I have 2 moments of time, s and t, and I'd like to forecast future value of x given my present information. And that should be, we have not checked yet, so maybe it's okay, maybe it's not, maybe this property is satisfied, maybe not, but that's a defining property for a martingale. Okay, let's check. Let's check what is Fs. Fs is just Sigma algebra x1, x2, xs. We know that xt is independent from x1, x2, xs. Yeah. Let's imagine t greater than f. Yeah. Xt is independent of x1, x2, xs. So by the properties of conditional expected value, we will use them. We will not prove them, not all of them. So we will use them as given. If random variable is independent of sigma algebra, then my information is useless to forecast, and then I can replace. I don't remember the numbers of the properties because they are arbitrary, so I don't care about the numbers of the properties. But it's important to remember that if my information contains nothing useful to forecast xt, then my best guess for xt is just
xt.
what? No. I don't know xt. I have no real. Sorry.
Expectation of xt.
Yeah. Expectation. Yeah, you're right. Expectation of xt. But expectation of xt is 0.4 times -1 plus 0.6 times 1. It's 0.2. And so we have proven that for t that is greater than s, expected value of xt given fs is just 0.2. And it's not equal to xs because this is constant and this is random variable. Okay, so our process is not a martingale. The best guess of future xt is 0.2 and has nothing to do with the current value of xt. Okay? Yeah? Yeah.
That is because xt is independent, right, from all previous x's.
Yeah.
That's why the conditional expectation is just the expectation of the variable.
Yeah.
Okay.
Okay, so xt is not a martingale. The same question about st. I need to calculate expected value of st given sigma given fs. Yeah. Let's imagine once again t is greater than s. So it's expected value of ss. Yeah, but okay, I think it's not confusing. It's okay. So plus x s plus 1 plus x s plus 2 plus finally xt given fs. Or maybe even, yeah. This value is known for me. I just know it. So according to the properties of conditional expected value, if I know something, my best prediction is the random variable itself. So it's ss plus expected value of x s plus 1 plus x s plus 2 plus xt given fs. and they are independent. So once again, I replace conditional expected value with unconditional. The expected value of each xt is 0.2. So I have SS plus T minus S times 0.2. Any questions?
Yeah, I have a question. I didn't get how you decompose ST.
What is S? What is ST?
Is a sum from x1 to xt.
Yes. And how can I decompose the sum? ST is x1 plus x2 plus x3 plus x, let's say 10. Imagine that S is 10 plus x11 plus x12 plus xt, and this is S10. So ST is just S10 plus new terms. Yeah.
Yeah, it's fine. Thanks.
So may I ask a question? So we get rid of the expectation for the SS. It's just because SS is an already observed thing.
Yeah,
right?
we have information about it. We have a property for, you remember there are two extreme properties of expected value. If conditional expected value, if you have no information about the random variable, so your FS Sigma algebra contains no information, so you just replace conditional expected value by unconditional one. And the other extreme, if you completely know a random variable, then you replace conditional expected value by the random variable itself. So conditional expected value of SS, if I have all information sufficient to calculate it exactly, so I know S number S, and in this case, my best guess of SS, if I know it, it's just SS. So it's other extreme. There are two extremes: when I have no information and when I have complete information. So the calculation of conditional expected value is easy in these two cases.
Thank you.
Okay, so once again, we see that it's not a martingale, because for a martingale, we should not have this difference. Yeah. Because for a martingale, we need that expected value of future, expectation of future value given current information should be current value. And we are almost there, but there is a nuisance term. And this nuisance term is not zero. So not a martingale. ST is not a martingale. Okay, let's move on.
By the way, SS it is not a random variable, right? It's like a constant,
Number.
or it's like
Yes.
set information. How we define it? Yes.
It's a random variable.
But observed. Supposed.
At which moment of time? It depends.
At S.
But it's a honest, yes.
Okay.
But it's a honest random variable. We can calculate its expected value. We can calculate variance. SS is a honest random variable. Once again, ordinary unconditional expected value is a constant. Conditional expected value of random variables of a random variable given some sigma algebra is a random variable in general. It may simplify to a constant, like in the case of x, yeah, but in general, it's like this. Expected value of a random variable is a constant, but expected value of a random variable given sigma algebra is another simplified version of original sigma algebra. Okay, now let's move on.
May I just to clarify? So here, even for the sum, our expected value of ST is still SS, right? It's not SS plus some part of another SX, let's say, which is composed of XS's.
No, I don't get your questions once again. So maybe I will add the line numbers. Let's say, oops, first, second,
yeah,
third.
So in the second one, we say that S plus T minus S times 0.2 is not equal to SS. So
yeah,
the Martingale states that expected value of ST given sigma algebra of S is equal to SS.
Yes, it's the definition of a Martingale.
It's like we get new random variables, x, S plus 1, S plus 2, but we don't account them in the sum. It turns out to be like this. Yes?
I don't get your point. This is a definition of a Martingale. This is a definition. A martingale is a process when the best guess of future state is current state. So when you say someone asks you what will be the weather tomorrow, you say like today. So in this case, you imagine that the weather is a martingale. It may be better, it may be worse, but roughly the same.
I mean, like so, we know that this is for xt, and we have now st. So isn't it different?
The definition of a martingale is the definition of a martingale. MT is a martingale if MT is adapted to. So please look in the book or in previous lecture notes. Anything is okay, or Wikipedia. Martingale, you just look at the definition before your eyes. So MT is adapted to FT, and expected value of MT given FS is MS or T greater than S. That's the definition of a martingale. So I apply it to X to S. So I check whether the best guess, this is the best guess of future value, best guess of future value, and this is current value.
Yeah.
The best guess of future value is not equal to the current value. So it's not a martingale.
Yeah, good, thanks.
Okay, now let's modify them to get martingales, because martingales are very useful. It's easy to calculate the expected values. So martingales are very useful. And basically, we will price derivatives using like, after this transformation, the price of a financial asset will be a martingale. For martingale, it's easy to calculate expected values. So we have calculated the price, equilibrium price of financial asset. So basic strategy in Black-Scholes model. There are many approaches. You can solve partial differential equation and so on. But the simplest one is the following. You just say, oh, the price of an asset is not a martingale, but oops, we have a transformation that transforms it into a martingale. For martingales, everything is very easy. So booms, we now can price a complex financial asset. So basically, the strategy would be like something xt is not a martingale, booms. you can transform. There are many things you can transform. You can see some f of xt, or you can change probabilities. So let's some zt to not confuse it. If zt is not a martingale, you can either create a function of it, or sometimes you can change probabilities, obtain a martingale, and martingales are too beautiful to be missed. So it's very easy to work with martingales. So the main strategy would be the following. Okay, let's consider point D, IBCD. First question, can you change probabilities? Can you change probabilities? I remember there was 0.6 plus 0.4. So propose new probabilities to make xt martingale, or propose new probabilities to make st martingale. So that is the question.
Well, for ST, it seems like straightforward. We may actually think of probability as 0.505.
Yeah, for ST, that's easy. I agree completely. If you consider the following modification, so modification of probabilities for ST to be a martingale, that's more or less easy. You modify probabilities to be equal to 0.505. And when you just redo all the calculations, expected value of st given fs would be s number s plus t minus s multiplied, but not by 0.2, but by 0. Yeah, 0.2 would be replaced by 0. And in this case, it's just current value of the process. And yes, I agree that we can change Martingale. Yeah, we can change probabilities to make st a martingale. Yeah, that's a correct answer. And can we change probabilities to make xt a martingale?
No.
No.
Yes. Why not? Let me see. -1, 1, and the probabilities at xi. Let's take some extreme case like 1, 0. What is the expected value of xt given fs? But xt is always -1. Yeah, so it's -1, but it's excess. Yeah, it's one modification mod for xt to be a martingale. And there is another modification. Which one?
0.1.
Yeah, we can modify like 0.1, and in that case, expected value of xt given fs, that would be just 1, because we have a very special random process that is 1, 1, 1, 1, 1. It's a very, very like special random process that is always one, and my best guess of future value is current value because it never changes. Okay, and in this case, the value of the process is always -1, and so the best guess of future value is current value. So because it's constant, so a constant sequence is a. So we may say that martingales are like generalization of constant sequences to random nature. Yeah, they are on average they are constant. Yeah, they do not increase on average. Okay, yes, Stepan, you're right. Okay, so martingale is something like analog of constant sequence for random processes. Like a little bit more intuition. It's not a formal definition. Formal definition requires two checks. That the process is adapted and the best guess is current value, but roughly. Okay, let's transform X and S into martingales, but not by changing probabilities, but by applying some transformations to them. So first, I don't know, maybe it's E. So first, let's create ZT, that is ST plus alpha times T. And my question is to find alpha such that, so I do not change probabilities. I go back to original probabilities. So now probabilities are original, 0, 4, 0, 6. So we have tried to change probabilities and obtain martingales. And now the other way, we apply transformation such that ZT is a martingale. So my first, find alpha. And if it's easy, then there is another powerful transformation. Find beta. Find beta such that so let it call not ZT but YT. YT is a martingale. YT is a martingale. So we create transformations to make martingales. So what is the value of alpha? I think
0.
How much? How much?
0. No.
No, if you take alpha 0, ZT is equal to ST, and ST is not a martingale. So if you take alpha equal to 0, so in this case, ZT is just ST, but ST is not a martingale. Alpha is a constant, so answer alpha equal to 0.2 times t minus s is not okay, because alpha is just a constant, like 5 square root of 3. It's not a function. Alpha is already multiplied by t. Uh, 0.2 more or less it's warmer. Yeah, you are getting closer and closer to truth, but not yet. Yeah, but the direction of your thought is right, but not yet. The final answer, yeah, you are going into the right direction. Yeah, we need a correction factor, but think a little bit in which way, in which direction should we correct that ST to make it a martingale? Yeah, almost right. Almost right. So what's the problem?
Maybe minus 0.2.
Yeah, minus 0.2, because why ST is not a martingale? Because on average, so once again, let's recall that expected value of ST given Fs for t greater than S, we have calculated it, and it was, it's okay, that is martingale, but there is a bias, yeah, like t minus S times 0.2. So on average, what's the interpretation of this fact? So the best guess of future value is current value plus some term. This is positive, yeah? This is positive. So to make it a martingale, we need to decrease future values more, yeah? Because the best guess of future value is current value plus something positive. So this process Ft grows on average. And to make it a martingale, we need to make it a fair game, like it can go up and go down. So we need to penalize the growth. So if it's growing on average, to make it a martingale, we need to penalize growth. And basically, we need minus 0.2. Yeah, that's the correct answer. So let's check formally. If I consider ZT, that is ST minus 0.2 times T, let's consider the best prediction of ZT given Fs. It's the best, it's ST minus 0.2 times T given Fs. We already know everything about the expected value of ST. So it will be SS plus T minus S times 0.2. So we have already calculated that, minus, because that part is non-random, because this part is non-random, so I just copy it, yeah? And I get SS minus 0.2 times S, but this is exactly definition of ZS. And so I have expected value of ZT given Fs is ZS, yeah? So ZS is a honest martingale, okay?
Yes.
So basically, S grows on average. Yeah, it may go up, may go down. It's a random process, S. But on average, it will grow. And to make it a martingale, we need to penalize growth. So we need to subtract our penalty for growth. Okay, and now for beta.
Excuse me, what have you written below SS in the expected? Yeah, here. Where is the expectation of ST given Fs? What is this below SS? It's constant.
Which line could you specify?
I mean, the upper one, where there is expectation of ST given Fs equals to SS plus T minus S.
This line.
Yes, -1, equation -1. And what is written below SS?
It's written okay for martingale.
Okay, thank you.
So with this term, we are satisfied. So the nuisance term is why it's not a martingale. S is okay for a martingale, but the problem is why S is not a martingale, because of this term. Okay, so let's consider YT is beta times ST. Okay, we use the same trick. First, beta is obvious. There are two betas to make YT, so we need YT martingale. One beta is obvious. The second one is less obvious. Which one is obvious?
Maybe beta 0, no?
0, it will not be defined because so if you say, because S can be negative, yeah, S can be like even S1 can take values 1 with probability 0.6, and -1 with probability 0.4. So if you consider 0 to the power st, then it will be either 0, either not defined, yeah, because you cannot inverse 0. So 0 is a, yeah, you are going into right direction, but not 0. There are two betas. One is obvious, and the other one is, yeah, beta equal to 1 is obvious beta to make it a martingale, because if beta is 1, then yt is just 1, yeah, because 1 in any power is 1. And basically, if you have a random process that is 1, 1, 1, 1, 1, so the best guess of yt given fs is 1, so it's a constant process, and it's a martingale. But there is one hidden value of beta that's very useful to study properties of Brownian motion, and we will recover it on the next page. But beta, when beta is equal to 1, it's okay that yt is a martingale.
Okay.
Thank you. Let's go on. Okay, now we need to find the other value of beta. What is the main condition? Expected value of beta times st given fs should be beta to which power?
SS.
ss. Okay. No, not -1. Okay, let me write st in terms of ss and changes. So it's expected value of beta ss plus xs plus 1. We have already done this. So we can decompose st into ss and changes. So that's the idea, to decompose a new value. New value is equal to past value plus changes. That's a good idea. We will use it when we study properties of Brownian motion, so it's a good idea. Beta ss. So okay, I can write it like beta ss times beta xs plus 1 xt given fs beta ss. So once again, this part, I have two extreme cases for the properties of a conditional expected value. This one is completely known. So my information is sufficient to exactly say the value of ss, and my information is independent. Okay. So I see there are two parts in my random variable. One which is completely predictable, and the other one I have no idea about it. So I will take out known part. So we have described the corresponding property of conditional expected value. We can take out of conditional expected value what is known. Will be beta ss multiplied by beta xs plus 1 dot xt given fs. That should be okay. And because beta is not 0, we can cancel out. We can cancel it because beta is not 0. When beta is 0, we have studied the process is not defined. So here we can simplify and take usual unconditional expected value instead of conditional expected value. And this is for every s. So we should have this equality for every s less than t. Okay?
Okay.
If
Sorry.
Yeah.
So we set it to beta in the power of SS because we want it to be a martingale, right?
Yeah,
Or
the question is find the value of beta. What is the question? Find the value of beta such that yt is a martingale. So find beta such that yt is a martingale.
Thanks.
So expected value of yt, future best guess given current information, should be current value of the process. Okay, it follows that just expected value for every this term should be 1. Yeah, because I can take s equal to 5 and t equal to 6, and I obtain expected value of x6. Yeah, so this is for any s. So let's take s equal to 5, t equal to 6, and I will have expected value of beta x 6 should be equal to 1. Yeah. So for every xi, we should have this equality. But basically, let's check x values of xy. Xy can take values -1 or xy can be 1. Probability is 0.4 and 0.6. And if I consider beta to the power xy, values are -1 to the power, beta to the power -1 and beta to the power 1. Yeah? If x1 is -1, beta to the power xi is beta to the power -1. Okay. And what is the expected value of beta to the power xi is 0.4 times value plus 0.6 times value, and it should be 1. Or I can multiply by 10 beta, and I obtain 4 beta plus 6 beta squared should be equal to 10 beta. It's a quadratic equation. Oops. Equal to 0. Or 3 beta squared minus 5 beta plus 2 equals to 1. There are two solutions to this quadratic equation. First, we have already guessed from common sense. Common sense says that beta, when beta is 1, we should have a martingale, and you can check that beta 1 satisfies this equation. And the other beta is
2.
2, 12 minus, no, not 2. Am I right? Like beta squared minus 5 over 3 beta plus 2 over 3 equals to 0. And this is the product of.
It's 2/3.
Maybe 2/3.
Yeah, it's the product.
Yeah, 2/3.
Viet theorem. So beta should be. That should be 2 over 3. Okay. So basically, we know that yt, that is equal to 2 over 3 to the power st, is a martingale. Okay.
Excuse me, could you please one more time repeat how we get that the expected or expectation of beta x to the power x zeta x equals to 1? It's above, like the derivation. Yeah, here.
We say that it's martingale. That's why it should be equal to beta to the power ss. Just our proposition.
Yeah, let's meet numbers align. Which line is not clear? The first, the second, or the third?
The third, Boris. Could you explain, please?
If the second is clear, the second should be, what are the quantors here? The second should be satisfied for any t, for any future t, and for any s.
Mm-hmm.
And I take s, let's take s that is t minus 1. So it will be only one random variable there.
So it should be satisfied for all s and t, right?
Yeah.
So if you like, okay, so if we take s equals to minus t, right?
S is like t, but less by 1. Less by 1.
T minus 1.
But what if it is less more than by 1?
Yeah, okay. Well, what is the problem? If you take s equal to, let's say 4 and t equal to 7, you will have beta to the power x5, beta to the power x6, beta to the power x7, and that should be equal to 1. Because random variables are independent, it will be beta to the power x5, expected value beta to x6, expected value beta x7, and that should be 1. But from this equation, the third one, it follows that this is also satisfied. If expected value of each term in the product is 1, then I'm sure that the product is 1. So if I consider any other s and t, this condition, the third one, is necessary and sufficient. Yeah, you see, it's necessary because if I plug s equal to 5 and t equal to 6, but if I but if this condition is satisfied for every x, for x5, for x6, I can multiply them and I get all conditions of type 2. So this is, honestly speaking, so condition 3 is necessary and sufficient for condition 2.
And what about the expectation of beta x zeta equals to -1? We can have the even number of -1s, and then we also have multiplication equals to 1.
Yeah, but you are saying necessary condition, but it's not sufficient. Your condition is not sufficient. Your condition is not satisfied if you take s is equal to 4 and beta and t equal to 6, then you're right, -1 can be, but you should write condition that is necessary and sufficient. So for all s, for all t. For this s and for this t, you're right, -1 is okay. But for that t, s equal to 5 and t equal to 6, your condition is not okay.
Yeah.
You're right. For s equal to 4 and t equal to 6, you can be satisfied with -1 there. Yeah, you're completely right. But that should be for any s, for any t. And the only way to proceed is to have 1, 1, 1, 1, 1, 1, 1.
Mm-hmm. Yeah, got it. Interesting. Thank you. Thank you.
Okay, so this process yt is a martingale. Okay, let's move on. What are the properties of a martingale? So let's, because we have said that xt and st are not martingales. We have transformed probability. So we have obtained martingales in 2 ways. We have transformed probabilities, transformation of probabilities, and that will be the trick we will use in Black-Scholes model to price options, and we have like xt is a martingale when probabilities are changed, yeah, and st is a martingale when probabilities are changed correspondingly. We have also transformed st in two ways, like zt is st minus 0 2 times t, and yt is 2 over 3 times st, and these are martingales. So my main point is that martingales have very easy properties, and let's check them. So first question, what is, so imagine that MT is some martingale. So my next question, what is expected value of, so my first question, what is the expected value of MT? What can be said? So let's, what can we say? What can we say about expected value of MT? If I look at the defining property of a martingale, expected value of MT given Fs is Ms. That's a definition of a martingale. So if I take expected value of both sides, then according to the Tower property of conditional expectation, I will get expected value of MT equals to expected value of Ms for any T and S. Okay, so it's a necessary condition for a process to be a martingale. It's not sufficient. That's a necessary condition. Condition for MT to be a martingale. That is not sufficient, but it's easy to check. If this property is not satisfied, then the process is not a martingale. And B, that works only in discrete time, because we have given a definition that is the same for discrete time, continuous time. This property will work only for discrete time. Discrete time. The one step ahead best guess, given that's one step ahead, should be according to the definition. According to the definition, that should be MS, because it should work for any T and S. But it happens that this property is necessary and sufficient. This property is necessary and sufficient for a process to be a martingale. And sufficient. Why it's necessary, it's more or less obvious. Yeah, you just plug in T equal to S plus 1 in the definition. Yeah, so that is necessary property, that it's more or less obvious. Just use the definition and plug T equal to S plus 1 in the definition. Why it's sufficient? Let's prove that this property is sufficient in discrete time. So when you work in discrete time, this property simplifies checking whether the process is martingale. The first property simplifies checking that something is not a martingale, because if the first property is violated, then you are happy. And this property is much easier to check than the general one we have used, because you do not consider all future T, you just consider one step ahead. This is So let's prove that it is sufficient. Yeah, let's prove that it is sufficient. Sufficiency proof. So what is expected value of ms plus 2 given given fs? We may say that according to the tower property, so let's check which sigma algebra is bigger. My first question, which sigma algebra is bigger, fs or fs plus 1? Which sigma algebra is bigger?
Fs plus 1.
Yeah, fs plus 1 is bigger. Yeah, so fs plus 1 contains more information. So let me start with from the informational viewpoint. Okay, now it follows that there is a tower property of conditional expected value that says that if two guys, there was, as far as I remember, Nikolai and Fedor last time, and then we were trying to predict the same thing. So expected value of some random variable, let it be r given fs plus 1 given fs. So if one guy which knows more is trying to predict r, and the other guy which knows less tries to predict the prediction of the first guy, then he just may try to predict r given his information. So it's a tower property of conditional expected values. That works for any random variable r and for any two sigma algebras when one sigma algebra is bigger than another. And if I plug in ms plus 2, so I will have expected value of ms plus 2 given fs plus 1 given fs is expected value of ms plus 2 given fs. But oops, I have, but I think it will be enough for me. Okay, and we believe in the one-step property. So because we believe that one step ahead property holds, then this is just ms plus 1, because we say that for any s, expected value of one step future value given current information is current value. Because ms plus 2 is just one step ahead of fs plus 1, then we just say that according to our assumption, this is just ms plus 1. So according to the tower property, we have ms plus 1 given fs is just expected value of ms plus 2 given fs. Once again, I apply one step ahead prediction property, and it says that is ms, because ms plus 1 is one step ahead of fs. And basically, we have proven that expected value of ms plus 2 given fs is ms. So starting from one step ahead prediction property, we have proven that the same relation holds for two-step ahead prediction. If I apply this idea twice, I will get the I can go further and conclude that expected value of ms plus 3 given fs is ms, and so on. And so that starting from just one step ahead property, I will conclude the general property for any t, and basically that proves the theorem. And conclusion that MT is a martingale. The formal definition is that MT is adapted to filtration FT. First point. Second point, that expected value of MT given Fs is just Ms. That's a definition. And we have one necessary condition that expected value of MT is expected value of MS. And for discrete time, this is a general definition, yeah, for S less than T. This is a general definition. It works in continuous time, in discrete time, so it's a general definition. Necessary condition for a process to be a martingale that it has constant expected value, and in discrete time we have a necessary and sufficient condition. First is MT necessary and sufficient. MT is adapted to FT, and we can just check one step ahead value instead of arbitrary future value. We can just check one step ahead future. If the best guess for one step is current value, then the best guess for any number of steps is current value. Basically, that's all for today. I think I will publish today a home assignment, so you are welcome to do it. If you have any questions, be brave, don't be shy, use chat in Telegram, use by voice, by any means. It's okay, but I think you are too shy, you are posing too you are posing so almost no questions. So I'm a little bit disappointed that there are almost no questions, because if you just take the book by Zastavniak, there are a lot of exercises solved. If you look at the past exams, I have already posted them. So if you look at past exams, many of them have answers, and some of them have solutions. So my only advantage is that I can answer questions. So be brave.
Boris Borisovich, may I ask a question?
Yeah.
Maybe мы вам надоели, but will you post the lecture, which was the day before yesterday?
Yeah, I will post it, but it takes time. Yeah.
Okay, thank you. Thank you very much.
Okay, so bye-bye. But once again, be brave, ask questions. There are no stupid questions. The stupid strategy is to be shy when you have questions. This is my opinion. So be brave. I encourage questions. So I will try to answer all questions in the chat. So if you'd like to be anonymous, you may send to me and say, I'd like to be anonymous. So I will put your question in the chat and under my name. So if you are shy and try to conceal your identity, so it's okay. I understand, but don't be shy. Okay, bye-bye.
Thank you, bye.
Thank you.
Thank you. Bye.